We'll go through questions 4, 5, and 6 of this assignment 2 on graphing rational functions. So P of x, it's already factored, so we can check that off. Wholes, well, x minus 2 cancels with x minus 2. What values of x make those canceled factors equal 0? And that's 2, so we have a whole at x equals 2. We'll come over here at x equals 2 and we'll put a little circle to remind us. Sometimes I put a little circle up here. Both are fine as long as we know what they are for. Zeros. So now that it is canceled, any values make the numerator equal 0. So to find zeros or x-intercepts, we look at this. And x equals negative 2 makes that equal 0. So that we have a 0 at negative 2. So we'll put a point there at negative 2. Vertical asymptotes are values that make the denominator equal 0. So x equals negative 1. So I already have that graphed in there. There's a vertical asymptote at x equals negative 1. Horizontal or slant asymptote, we have to look at the degree of the numerator compared to the degree of the denominator. And so looking at the degree of the numerator, we have a 1 and a 1. So that's an x squared. And then the degree of the denominator, same idea. It's also x squared. So they're equal to each other. So once we canceled, though, we could have thought 1 and 1. Regardless, they both work, so you can't work through it before you cancel or after cancel. They're both equal to each other, so we look at the leading coefficients, which in this case it's pretty easy to see is 3/4. So we have a horizontal asymptote at y equals 3/4. Y-intercepts, we can put 0 in for x. What we'll do here is rewrite this without our canceled factor. Put 0 in. We probably can just do this mentally, but let's throw 0 in there. Oops, sorry guys, that's a 1. And so we have 2 times 3 is 6. And 4 times negative 1 is negative 4. So I did this differently. I put it into the original. So either one. So I got a 6 over a 4, which reduces to 1.5. And so we have a y-intercept at 1.5. And now we need to graph this. So we have one asymptote, which splits it into 2 parts. So we're going to have a section in the left side and on the right side. So let's try to figure that out. We have one option to have this black one like this, which doesn't seem to work. The orange one would look like this, which makes more sense because we do have to go through this x-intercept and get closer. So it's not the black one, it's the orange one. And then we can use the idea of our vertical asymptote is multiplicity 1. And so these have to go in the opposite direction at that asymptote. So to the left went down, the right needs to go up. So that needs to go up, and then it comes down. It will hit our y-intercept. Now remember, this circle here doesn't mean anything for our sketch, like where the graph is. It just tells us later on, like right now, that I need to go back and put a hole in the graph at x equals 2. So I'm going to erase that and then put an open circle. And then after I do that, I actually like to get rid of this circle anyway, so it's not there. So there is the graph of P of x. Number 5. Number 5, we actually had to factor. So in the numerator, there's an x in common. So factor it out an x. So x times x squared minus 1 over x squared minus 1. However, x squared minus 1, we could just cancel them there, but we have to be careful because we have to know what values of x make that 0, which we probably could think through. But I know that this factors again because it's a difference of squares. So it factors to this. Same idea on the denominator. So cancel and then cancel. And what values of x make those canceled factors equal 0? That's -1 and 1. And so we just factored. We have wholes at -1 and 1, or we could put them here. Either way is fine. Now what's unique about this, after they cancel, all we're left with is this x. So we're just graphing y equals x. So there's an x-intercept at 0. I mean, in fact, we know that's a line, so we could just graph that line. There's no vertical asymptotes. There's no slant asymptotes. So we want to graph this line, y equals x. So y equals x has a y-intercept of 0, slope of 1, so up 1 over 1. And so it's the graph of this line. Down 1, left 1. However, we have some holes in the graph. So we get our eraser, and when x equals 1, we put a hole, and when x equals -1, we put a hole. And so our graph turns out to be a line with 2 holes in that line. And as I said before, I do like to get rid of these holes. So graph is simply a line with 2 holes in it. Number 6, factoring. The numerator can't really factor, but the denominator, there's an x squared in common, so we can factor out an x squared. We're left with x minus 1, x to the 4th, and x squared cancels to have an x squared on top. Well, what made those those canceled factors equal 0? Well, x equals 0. There's a hole at x equals 0. As we continue to work through it, which we'll talk about in a minute, it's actually something unique about that we'll talk about. So factors, holes, zeros. Zeros are values that make the numerator equal 0. So x equals, I have this mixed up, x equals 0. So this isn't actually right. X equals 0 is a 0. Now, as we get there, we're going to graph this. We're going to use the fact that it would have an x-intercept of 0. However, there will be a hole there. So this part helps me figure out where the graph of the whole thing will be, but then it turns out there's actually going to be a hole in the graph there. This is wrong. There's a vertical asymptote at x equals 1, which, funny enough, I have correct over in the graph, just not here. So I'm going to put a little dot here at x equals 0, although there's not going to be a 0 there. I'm going to put a circle here to remind me that or I can even put a circle here to remind me that there's a hole in the graph. There's no y-intercept, kind of. We could think 0 again, but again, there's going to be a hole there. All right, so how does this work? We're still going to just run through our same ideas. So we want something to the left of the vertical asymptote, and we'll have something to the right of the vertical asymptote. So let's figure out what goes there. And so as we think through this green part has to get closer and closer to the y-axis. It would have to come through here, but it can't be this green one because there's no x-intercept here. So can't be that, which means it has to be the lower one. And so vertical asymptote goes down, comes up. We're not worried about the hole yet. It would hit this 0, which I didn't write it, which is really bad. This 0 here is multiplicity 2. So this should have had an x here. And so it has to hit that. It bounces and goes back toward down toward the slant asymptote. Our vertical asymptote is x equals 1. It's just multiplicity 1. So since it was down to the left, it has to be up to the right. And then it's going to change direction here and get closer and closer to the slant asymptote. And also we could know it's this upper branch, because if we tried drawing the lower branch, it would have to go through the x-axis, and we know there's not an x-intercept there. And so the last thing we need to do is take into consideration this hole that's in the graph. So I'm going to come over here, put a hole here in the graph. I had a lot of writing here, so let's get rid of this writing. So there's a hole at 0, and then looks like that.